Hi all, my name is Professor Charles Myers. Today I am presenting the paper Experimental Analysis of Microservice Architecture for Hosting Cloud-Based Massive Multiplayer Online Role-Play Game, also called by the acronyms MMORPG. This work was developed by Marlon Schweidert. He was my undergrad student, and this was the result of this final monography. And also with collaboration with Diego. Diego is a candidate to masters here, and also Professors Guilherme and Professor Mauricio. First about our university, most of people doesn't know UDESC. It means Santa Catarina State University. We are a university in the south of Brazil, in a state called Santa Catarina. We are here in the south of Brazil, and we are multi-camp universities. We are a public university offering graduate courses in several areas like computer science, health, agronomy, science, administration, economics. And our campus that is depicted here in this picture here is the campus related to technological sciences, computer science, and generally mathematics, chemics, and physics. I am Professor Charles. I am currently head of the graduate program in applied computer until December of this year. Next year, 2024, I will not be head anymore. I got my PhD in electrical engineering, University of São Paulo, almost 12 years ago. And I got my master's degree at Universidade Federal Santa Catarina, it means Federal University of Santa Catarina, and I got my undergrad in the same university that currently I'm teaching. I have experience with similar projects in cooperation with Brazil and Europe, like Ericsson Research, as well as USA with IBM, Harvard Packard Enterprise. I am also journal reviewer, journal guest editor, organize conference, and review a lot of theirs. So, what's the goal of this paper when you create it? The main idea is to analyze the resource consumption of root, cells, and Whistle microservice architectures for MMORPG games. And you start to be wondering, why do this research? Because Marlon, that is the undergraduate student, he already worked in some companies like Blizzard, and there is a problem in dimensionate and visualize which is the better architecture in order to deploy a new game. We started this study with the goal to analyze these architectures. And the specific objectives, we want to identify in these architectures which protocols are employed in each one, identify the microservers of these architectures, as well as identify the evaluate metrics and define metrics themselves, as well as the analysis tools to be employed, analyze the behavior of the applied architectures. So, the first context here is what complains an MMORPG game. Basically, you have a client, you have a server, and you have a service. Client user are the players who wants to play the game, and we have a server which is hosting the game themselves, and the services here that are the game and all the services supporting the game works correctly and flows in a good quality experience to all the users involved in the game. So if you look here, for example, one game you have here, you can see like one player here with other players here. They are interacting. They are basically using a map here, and this is just a part of the map. Usually we have huge maps, and these maps depends of the games. So when some games they go to the same map, they can fight or they can collaborate in different tasks or different kinds of games depending of the game they are playing. And we identified some architectures, and then you guys should be start to wonder why these architectures, because they were the only one we found in the literature. Of course, you want to use architectures that some big studios like Bethesda, Blizzard, and others are using, but some of them are not public. But we identify these here public architectures already employed in some open source games. So we started with these architectures here, and they are very peculiar because there are some study, some of the results we need implement these games, deploy in machines, and see how it works in order to get results. So another contribution of this paper here is also define these architectures and also put in the same level that allows it to compare with each other. So the first one is the root architecture. As you can see here, we have some elements here, the client spheres. You can see that it relies on a lot of TCP servers based on remote procedural call in HTTP. And here we have the communication intern between the servers. We have like Redis, we have PostgreSQL, and servers interacting with each other. SaaS architectures, you can see that there are more elements here, but it also relies in TCP, here more remote procedural calls and HTTPs. We have some servers of games, web servers, chat servers that are very common in this type of game, authorization servers, and here some interactions between them. And most of the servers used are deployed as containers or virtual machines. And the last one, the user architecture, that also have here, you can see that there is many requests between them, and how they interact with the main servers available here in the architecture. So a first glance of analysis these architectures, you can simplify some aspects, like if they allow to do chunk processing of the request. We can see that some architectures allow it, that means yes here, others not. If they have microservice queries, if they execute requests in parallel, if they allows multiple connections, if it allows provide authentication of the microservices, if it caches the database usage, and also if it transfers between the services via database. And you can see that they are very different. There are no common aspects between them. Some of them implement some servers, others not, and that's why, because they are sometimes planned for other kind of games. In one game, sometimes the dynamics requires more one aspect than another, and sometimes it relies on the developer choices. So what we do to test it? First, we try to define a scenario and separate the client and the services, and create an architectures that allow a fair comparison between the three analysis architectures. And how we do that? We create a test plan here, in which we have like the game services, we have the game server databases, we have like the data services, we have clients. We launch several clients here, and we create all the services using virtual machines and containers in architecture that only allows we need only to change some of the aspects, and can deploy different architectures in the same test bed without the need to change aspects that may affect how fair the comparison is. And how is the phase implemented? We have like a Docker swarms in order to deploy all these machines, and we have a lot of clients here that simulates the players in the gaming. They do different activities, like they move, they go to other parts. We need to automate that. And here we have also the virtual machines running the service, and we deploy a lot of this information here and create each architectures. And how it was really in our architecture, we have our private cloud here in university, in which we use OpenStack. At this time it was used OpenStack Victoria, in which in these hosts of the OpenStack here we have the services. Because if you put the clients play the game inside the cloud here, it will be not a fair comparison with a real scenario. What we did, we used the labs at the university that usually people develop software and do other activities, and we deploy all these players here as different machines here. In each machine, like several players going to the university local area network. Before you ask, okay, but the local area network maybe have different traffic, different experience. We do it in the weekends, in some holidays, when we are sure that there was no other traffic than ours there, so we can deploy in a scenario that is very realistic. So, in how we simulate the clients, because a client usually goes in the game, he creates a code, then he creates a character, he can choose his abilities, these stuff. But after it's created, start to play the game, what is the typical actions of this personage here? It usually authenticate, it move, each communication like chat message to the users, move again in different maps. So we create some robots in the player, so we don't need only to launch the clients, but we also need to launch the clients and make they seems very realistic, because if you do make they do different things at each experiment, again we will not have a fair comparison between the different architectures. So we produce the similar moves in all the architectures in order to be really exactly the same procedures in all the architectures. To don't say that in one architecture maybe the results were affected by different movements of the players. So we create robots here and we automated these clients. So we are sure that all clients have the same behavior and we produce the same results. In which actions you have here? Like we have actions like authenticate, create user account, and which kind of service and protocol they are using. They use HTTP with the JSON requests here encapsulated inside. Here you have your password. You have some of the arguments used here that are the arguments to each server, and we also monitor it in real time. Despite it show to you guys in the article here only the results final, we need to understand if the behavior was happening really according to our plans, if there is no irregularity or error during the experiment, because we let the experiment run for some several hours. So we also developed a real-time here dashboard in which allows you to monitor several metrics while we are running the experiment. So we don't need to finish the experiment to have a first glance of how were the results of each experiment in each architecture. So as you can see, because we have several tasks, several architectures with several elements, of course it results in 60 comparative graphs and more than 20 tables. So it will be very boring if you put all this information here. Even in a journal paper it will be really big. The monography got more than 120 pages, so it's really almost a master. Some people say that it's almost close to PhD. And we choose just one of the these comparative here and put the consolidate analysis here in order to provide our results here and do our contribution. So here, the experiments we choose here just to show you one of these graphs here is the microservice memory usage. So here over you have each architectures. You can see here the time the experiments runs and the number of clients. So we start to launch like a number of clients and then we're increasing clients each time in the time and see how the performances of the architecture is affected or not. Here we have the same experiment for the sales architecture and as well as user architecture here. And here we have one of these results here in which we divided all the authentications here. The first letter means the architecture. So here's Rudy, here's sales, and here's user architectures. Divided in the percentages of the coordinates like a box plot, but in the format of a table. But the real contribution here is this table here, because we proposed in the beginning to compare the architectures regarding performance like time response, CPU consumption, memory usage, network input, and network output. And here this table really consolidates all this information. So the biggest contribution of the paper is in this table here, in which you can discuss and see that for some aspects some architectures are better than others. We can see that some architectures like Wilson's, that in the beginning can be show the more simple of all of them here, but it got scored some results better than others. But for example, in CPU consumption, the better architecture was Rudy or South. So depends how you create your MMORPG game and which aspects are you looking for. Maybe you can use our results here to guide you to choose the more correct architecture which provide the better results. So the research architecture showed the less response time justified by the better occupation of CPU and direct connection of the database. Sales architecture showed the lowest response time justified by providing the authentication microservice in a public way for connecting by the client, decreasing the chain of connections needed to perform authentication servers. And the user architecture shows the shortest response time justified by the better CPU utilization. User architecture showed the less response time justified by the better CPU utilization. So we validated our behaviors here, and we identified also some bottlenecks, like in some servers here, games, and separating here. We also identified the CPU consumption related to the number of microservers launched, in each virtual machine, or even some containers in some cases. And the backend architectures, of course, depend on dynamics predicted by the developers. And our difficulties here first was to identify the game architectures. We got just this three one because there was the only one we found regarding this game. If some developers provide the architecture, we can conduct new experiments and they will be really interesting. Of course, it also is a reference-based data for people looking for characteristics of game architectures that really a lot of people talk about, but we really see few results carried out using academic metrics and methods. So for future work, we are working resource usage predictions like linear analysis, linear regressions here. We are also doing analysis of impact of changing databases. Different databases may impact the performance, and optimization of the communications protocols, because as you see, most of these services use HTTP. We want also test this service running HTTPS, which includes TLS and should include some delay in the communications in the service. And analysis data is captured but not analyzed because we have like more than 1 terabyte of data regarding these works. Here are some references, and now are open to questions. So if you don't have questions right now, but you read the paper or you are seeing these presentations, you can send emails to us, and you'll be very glad to answer all questions you have. This work was provided with a series of with fundings of Santa Catarina State University, as well as CAPES and FAPESC, and I am open to questions.